right? Hey Neil. So we look there. So we had a makeup class on Wednesday, which for which I had informed everybody, but only few kids joined. That should be okay. Anyway, there is nothing lost. I had clubbed that with the pre-calculus class because I could not do the class on Saturday, so that's why we had a makeup class on last Wednesday. But even if you missed it, no damage done. You guys can watch the video of the class, and I'm anyways going to come back to the topic one more time, so don't worry about it. So first of all, I must apologize you all for having a class today. There is a festival called Diwali on Monday, and I know everybody is having something or other happening at home, but we will keep it as interesting as possible, so that you guys at least see some motivation for what we are learning today. So in the previous class on last Sunday, we started talking about volume and surface area. Do you guys recall that? Come on in. Okay, I'm not alone. I'm not feeling scared now. I have Tony with me. Hello, Emily. Hi, Sharanya. Hello, Nanya. And Tony, one request to you would be, whenever you are sitting on this table, right, just check if it is firm or not. Sometimes what happens is it becomes little loose. Not this one, the one that you are sitting on. Sometimes it is little loose, it flips.
Okay.
Because it's a lightweight one. Alright, so we have a new child in the class named Emily. Hi Emily, how are you?
I am
Good. So, Emily and her mom, Emily's mom and me, we worked together in our previous company, okay? So that's how we know each other. So thanks Emily for joining the class. Couple of things that I would want you to be aware of. In this class, when I'm teaching this is for SAT preparation, where we have kids from 9th grade all the way to 11th grade. And in next 1.5 year, we will cover the entire syllabus for SAT that you would need to prepare for at least one iteration, if not more. Okay? And in this class, our goal is primarily to focus on understanding or learning the concepts, and we practice those. So when I'm teaching you guys, you don't have to worry about taking notes or making sure that you are not forgetting anything. You don't have to take notes, okay? Your focus should be on understanding and following the concepts, and everything that I'm doing, me and the board, that is getting recorded, for which I upload the video of the class later on that you can watch and do whatever revision you want to do, okay? So in the class, I expect all the kids to participate with me, and I call you guys kids, okay? Because I have kids who are of your age or even elder than you guys. So that's why I call you guys kids, okay? So feel comfortable, don't be afraid of making mistakes. If you are making mistakes, if you are getting some idea and you want to share, don't even stop yourself saying, okay, will this be a good thing to say or bad thing? I mean, again, it's going to be around maths only. We're not going to go anything outside math, but don't be afraid of sharing your point of view, okay? Because that's when we get opportunity to correct ourselves. Alright? Is that okay, everybody? Emily, okay with me? Yeah. So right now we are doing a unit which is around volume and surface area. So we just touched upon what do we mean by volume. We tried understanding what is surface area. Since this is our first class and we have covered a little bit of it in the previous class, and we are going to do more around that in the class today. Emily, do you want to share what is your understanding of volume and surface area in the simplest possible terms? Everyone.
Can you say that again?
What do you know about volume and surface area? I mean, if you have to teach that to me, like I'm a 5th grader, let's say, and you have to explain that to me, how would you explain what is volume and what is surface area in simplest possible way?
It's been a while since I've
Okay.
been taught about that stuff, so I don't really remember.
Okay, don't worry about it. So, simplest possible definition. I'm just trying to help you guys recap or recollect what we did in the previous class. First of all, everybody online can see the whole board, right? From beginning to the end. Ritika, Emily, everybody from beginning to the end. Okay, all right. So when we talk about volume means volume of any object. I'm talking about a 3D object. So anything's volume means the space that it takes. Look at this versus look at this. This one takes more space, this one takes less. This one has more volume, this one has less volume. Now if you are comparing this with this one will take less space compared to this one, correct? So in simplest possible way, volume means the object taken by any three-dimensional object. When I say three-dimensional object, I'm essentially talking about something which has length, width and height. Is that okay? Now, if I talk about a surface area, now if you look at the bottle that I'm showing you guys, I mean this is for Tony, I think. This one is a mosquito repellent. If there's any mosquito found around, you can spray this and keep the mosquitoes away. But on a serious note, this is colored blue and a little bit white. If you have to find out what is the surface area of this one, what essentially you are talking about is the amount of paint that you would need for coloring it, right? Imagine this one versus this one. This one needs more paint if I have to color it in a different thing, right? Because surface area means the area that you see on the surface of it. And that's what we essentially covered in the previous class. So if you have to, if you don't like the way I look, and if you want to color me, let's say yellow, my surface area is the part of the body that is exposed outside, which you would want to color if you want to make me look better, right? So surface area is nothing but the area of the surface, something that you see from outside. You don't have to cut me open to color me, yeah? Don't get those ideas. I'm just telling you guys what it means practically, correct? Now, in the previous class we talked about cuboid, cube and right cylinder. Whatever I'm showing on the board right now, I'm calling this a cuboid, I'm calling this as cube, and I'm calling this a right cylinder. Am I making sense or I'm not? Am I telling the truth or I'm bluffing right now? I'm saying this is cuboid, this is cube, and this is right cylinder. Am I being true or I'm bluffing right now? And guys, be brave. You can challenge me if I'm saying anything wrong. Nobody's brave in the class? Tony, does this look like cuboid? No, it is not. I was bluffing. See, that's why. See, you guys don't have to be afraid of me, okay? We are here to learn things. This is a rectangle, this is a square, and this is a circle. This is not cuboid, this is not cube, and this is not right cylinder. Correct? Because these are two-dimensional shapes. It has length and width. There is no height. Length and width. No height. And this is a circle. It can be drawn on a piece of paper. There is no height here. Now, but these shapes give birth to the shape that I was talking about. And then this cylinder, this is not right cylinder. Right cylinder would be like this. Yep. Now, can you guys trust me? Emily, Niels, Ritika, Sarah. This is a cuboid, this is a cube, and this is a right cylinder. Yeah. And see, sometimes I try misguiding you guys on purpose, just to make sure that nobody is feeling sleepy after a heavy lunch. Okay. So if I'm trying to wake you guys up, there's a reason for doing so. Okay. Now, but there was a reason why I was drawing a rectangle and a square and a circle and saying that this is cuboid, cube and cylinder, because when you have a rectangle, when you add height to it, then it becomes a cuboid. You look at my phone. From one side, it looks like a rectangle. But if you look at this way, you see that, okay, this is not only length and width, there's a height also. That is how it became a cuboid. So basically, when you have a rectangle, you keep stacking one after another of the same size and add height to it, that became a cuboid. If you have a square, and you keep stacking square of same size, same dimension over and over again, and add it such that your length, width and height all are same. Basically in the square, your length and width are same, right? So if you are adding a height which is also same as your length and width of the square, I mean again, square doesn't have length and width, it has only length. So when all the three dimensions, length, width and height are same, that is when it is called a cube. Here you have length, width and height. Now when you look at a right cylinder, it is nothing but you have a circle, you get probably hundreds of circles of the same size, keep stacking one after another. Imagine this, I mean up to this height only. There are so many circles stacked one after another. If you look at the bottom, it's a circle, but then there are so many circles put one after another, and that's what made the right cylinder. Correct? Do you guys remember it, or I'm still bluffing? Vishal, Sarah, Neil, Jenna, are you guys with me so far? Tony, okay?
Yes, sir.
Okay. So don't go by my face value, okay? Whatever I say, they will not be 100% correct always. Sometimes I'll have mischievous plan to misguide you. And that is when I would expect you guys to think and correct me, okay? Alright? Emily, so far you are with me?
Yes.
So this is your first class beta, okay? So when I say beta in my mother tongue means son or child, okay? So if I use that word, I'm addressing you as my child, okay? So now, since this is your first class, I'll keep calling out your name, Emily, a couple of times, because I'll try to make sure that you're able to follow the speed at which I talk. You're able to make sense out of whatever I say, okay? And if I don't, please don't hesitate to stop me or ask me to slow down or repeat, okay? Now, in the previous class, again, I'm not going to redo whatever we did in the previous class. Tony, okay? Okay. So, I'm not going to redo whatever we did in the last class. I will, whoever in the class had missed the last class, I will suggest you guys to go back to the video of the last class. I'll probably put the link again if you want me to, so that you can watch the video and revise, so that we can continue. But then, after watching the video, if you have any doubt, please feel free to ask me. I'll explain that again. But here, now we are looking at these three basic shapes, or three-dimensional objects, meaning all the three of them have length, width and height. Okay? So, what we learned was, these shapes, if you have to find out the volume, meaning how much space it takes, what you do is, you look at the area of the base, find out the area of the base and multiply that with the height. That will give you the volume. So if you're talking about cuboid, your volume would be area of the base. So this is the base, length times width. This is your base, length times width. Multiply that with the height. This became your volume. If you're looking at the cube, again, area of the base, meaning this shaded area. The length into length, because length and width are same for cube. So length into length, this is the area, times the height. Again, your height is also same as your length and width. Length cube, okay? If you look at the area of a right cylinder, area of the base, okay, what am I writing? I'm out of my mind. This is the volume of cuboid. Here, instead of saying cube, I said cube, and this is the volume of the cube. I'm just relating it. This was length times length times length. Right cylinder, again same thing. Volume of right cylinder would be equal to area of the base. What is the area of the base? Meaning area of the circle, pi times r square. This is your radius and this is your height. area of the base times height, pi r square h. Do you guys remember it, recall it, or anybody in the class forgot it? I mean, there's nothing to remember. We all know area of a rectangle is length times width. Your base of the cuboid is a rectangle, length times width, and multiply that with the height. Area of the cube, volume of the cube will be area of the base, and the area of the base is this is square, length times the height. Volume of a cylinder would be again pi r square, that is the base, times the height. Yeah. Is everybody with me? Jana, Sarah, Neil, Emily, everybody? Yasmita? All right. Now, there are some little tricky aspects, or there are some objects which are little tricky than the simple ones that we saw just now. Can somebody tell me what is this one called? Anybody? Have you heard us? Yes, that is a cone. What is the volume of this guy? See, when we are looking at the cuboid, cube or a right cylinder, our volume was simple. Find out the base, multiply the area of the base, multiply that with the height. Find out the base, multiply that with the height. Find out the area of the base, multiply that with the height. Here, can I do that? Think. Time to think, challenge yourself.
Don't you have to find like the slant height?
One more time, brother.
Don't you have to find the slant height?
Okay.
Try.
A little different, brother. Okay, let's see what Jenna says. Yes, Jenna.
Can't you not make like two right triangles first, and then you solve for the circle?
Right. So that will be your way to solve it using calculus. We are not learning calculus yet. Okay. Yeah, Praneeth. Exactly. So I'm trying to make it a little simpler, or there are two three-dimensional objects that we'll talk about. Okay. And I will try my best with my worst drawing skills to make you guys understand this. So let's look at two objects. One, I'm talking about cone, and then I'm talking about right. No, not right. Rectangular pyramid. Okay. And only thing you would want to keep in mind is cone uses this as your base, your right cylinder as a base. Imagine this. What did you do? You had a right cylinder, you actually cut that into two pieces. Here, what you did cut this into three pieces actually. Look at this side. Where did I get this pen? It doesn't work. Look at the red part and the blue part here. Imagine this like you had a right cylinder and you split this into three parts. Here again, a little bit of visualization would be needed because we are not leveraging calculus yet. And if I go to calculus, that will make it more complicated. But think of this like you had a vertical line with which you are splitting this into two parts, and then you are taking the middle one out, and then here you have two separate pieces. For the sake of simplicity, there are three parts that you are seeing, and if you basically deal with this physically, you will see that the red piece will again become another cone, this blue piece will again become another cone, and all of them will have the same radius, like what you see here, here to here. So we saw the volume of a cylinder, I'll put a C, is pi r square h. When you split this, when you break this into three pieces, and you will literally get three cones out of it. So that's why the volume of this cone, volume of the cone in the center, this will be 1/3 of the volume that you will have otherwise, for 1/3 of the volume of a cylinder, because you have two pieces out, and these will roll up to make another cone. So you'll have one red cone, one blue cone, and one cone that you see in the center. Okay. So basically, the simplest way to relate that would be a cone is made by pulling out 1/3 of a right cylinder. So that's why the volume of a cone is 1/3 of the volume of a cylinder, which is pi r square h. Am I going too fast? Are you guys able to relate? Jana, Yasmita, Sarah, Neil. Okay? Emily, okay? Alright. Vishal, ready to accept this? Ritika, everybody okay? Similarly, so just because we're not talking about calculus right now in this class, that's why I'm not trying to break it down into the calculus way to find out the volume for you guys. The way you will relate this is, or the way you will visualize is, you have a right cylinder, you can get three same size cone out of it with the same height. Okay? And that's why volume of one cone, volume of that cone, which has the same height as the right cylinder, and the area of the base has the same base of the cone has the same radius as the cylinder. The volume will be 1/3 of the volume that we'll have for a right cylinder. Similarly, again, this is one problem I'm dealing with right now. So this is my this shape I'm calling as, this is a right pyramid, rectangular pyramid. So we had a cuboid, and we did the same thing. What we did was, we said, okay, fine, we want to we took a 1/3 of the cuboid also out. That's what is called a rectangular pyramid. So imagine this is my cuboid. This is my cuboid, and instead of taking the whole cuboid, I will cut it into three pieces. Okay. I drew a triangle here in the middle. So it will become a tapered shape where the base will have the same area like this, but at the top it will be like a thin line. So that's what is called rectangular pyramid. Here also you can, as I was saying, what did I do? I cut this into three equal pieces. So here also, whatever is the volume of your cuboid, the volume of rectangular pyramid will be 1/3 of the volume of the cuboid, which will be pi r, it's not pi, length times width times height. Are you guys with me so far, or I'm getting you guys more confused? I know these are a little tricky shapes that we don't see very often, and I'm kind of struggling right now to see if I can show you guys something which looks like a rectangular pyramid. or a cone I can show you. Cone is easy. You would have seen a cone, right? I mean, like a funnel that you use for pouring oil into the bottle with a narrow this thing head. So it looks like this, but it's very different from a right cylinder, correct? So we saw that a volume of a cone would be 1/3 the volume of a right cylinder, because I'm just asking you guys to visualize that if you are cutting a cone into a right cylinder to 3 equal pieces, every piece is a cone, and the volume of that is 1/3 of the volume of a right cylinder, which is 1. So and hence the volume of the cone would be 1/3 of pi r square h. Similarly, for a pyramid also you are seeing that when you have a cuboid and you split this into 3 shapes where the base is a rectangle but the top it becomes a thin line, so your sides are tapered, not symmetric. So the volume of rectangular pyramid is also 1/3 the volume of the original cuboid, because you're literally splitting this into 3 parts. Am I kind of making sense so far, or it's getting confusing? Okay, all right. So what all we have covered so far? We talked about volume of cube and right cylinder. Then we talked about the volume of a cone and volume of a rectangular pyramid. There's one more shape that doesn't need any, doesn't have any identity crunch. A sphere, a ball, a football, whatever, a soccer ball basically, not a football. When you're looking at a sphere, same thing, volume of a sphere is, this is something I will force you guys to memorize for now. It is 4/3 pi r cube. Okay. The area of a square is pi r square. It's 4/3 pi r cube. That's the volume of a sphere. If you ask me how, this is based on experimental data. That is how it is derived. So I don't think we can prove it right now. For now, we will assume this is the volume. But we just touched upon what are the different things, different shapes that we know about, and how do we find out the volume of these shapes. Once we deal with some problems relating to these shapes, I think then it will make a little more sense. Okay? Once we see the application of this, then probably we'll get a little more conversant. So far summary of that is, if you are trying to find out volume of any shape which is symmetric in nature, meaning the base and the top have the same area, like a right cylinder, a cuboid, or cube, you find out the area of the base, multiply that with the height. Done. If you're talking about shapes like cone and rectangular pyramid, where at the bottom the area is like a rectangle, and then at the top it becomes tapered. It doesn't remain symmetric. Okay, it is 1/3 of the volume of a regular cuboid. And if you're talking about a cone, it is again tapered version of a right cylinder. That will again be 1/3 of the volume of a cone. 1/3 of the volume of a rectangular right cylinder, not rectangle. Okay. So these are the things that we have learned, and then we saw that which I don't do very often, but today I kind of forced you guys to memorize the formula for volume of a sphere, which is 4/3 pi r cube. Now, this is just laying the foundation stone for what we need to know about from a volume perspective. How about surface area? Again, we touched upon the surface area of a cuboid, cube, and right cylinder. And again, I'm bluffing right now. This is a cube now. This is a cuboid now. Surface area. Here, when you see in the case of a cuboid, you saw that the opposite sides are same area. Okay. So there are 3 pairs of equal areas. one in the front and one in the back, one on the side, on this both the sides, one at the top and the bottom. And in the previous class we saw if this is length, this is width and this is height, 2 times the front area, 2 times of this area plus top area plus side area, because this side and this side are same, this side and this side are same, this one and back is same. So 2 times of front area, which is length times height, plus 2 times the side area, width times height, plus 2 times the top of the area, which is here, this is length and this is width, length into width. So your cuboid has length, width and height, and you will see that these are 3 combinations of length, width and height that is added together. So length times width, width times height and length times width. That's what gives you the surface area of a cuboid. And again, I'm going a little fast here because so that we can do a little more practice. And kids who are failing to recall will have to just watch the video one more time, and that will make it easy. When you're looking at a cube, your length, width and height are all same. So all the sides that you see are same. So your surface area will be equal to 6 times one of the area. 6 times one of the area. Again, everything is same. If you take this as the area, 6 times of this area. Length into length. That's it. When you're looking at a right cylinder, I'm not going to derive this right now, but what we saw was, if you're talking about surface area of right cylinder, you're talking about essentially two circles area at the top and the bottom. So 2 times pi r square, this radius is r and this height is h. And then the area of the curved surface is 2 times pi times r, 2 pi r h. And now you will say why h? So if you unfold this, so curve that you're talking about, what we are doing is we are just opening it, and then this whole thing, the perimeter opens up, and that becomes one of the sides of the rectangle, and this is your height anyways. So 2 pi r into h, that is how we got this surface area, which is 2 pi r square plus 2 pi r h, or for sake of ease for memorizing it, 2 pi r into r plus h. I just took 2 pi r common out and became the surface area of this one. So Emily, I'm pretty sure you would have not come across this recently, and I'm rushing through it. But then, if you look at, see, all these formulas that I'm talking about right now, you don't have to memorize any of them. It's just about how do you relate. If you can visualize the object that we're talking about, you will see, okay, there are three pairs of opposite sides, and every side's area is this. So 2 times the sum of the areas. Okay. Similarly, if you look at a cube, you know that in the case of a cube, length, width, height all are same. So I'm essentially talking about 6 equal sides, 6 times every side, and this side is length times length. Okay. And then you're talking about right cylinder, same thing. You have 2 circles, one the top and the bottom, and then the curved surface that you are seeing. Basically, this circle's area and this top circle's area, again, this is not symmetric, but assuming if it was a perfect right cylinder, this area pi r square, this area pi r square, and then this curve, which I'm just cutting it open. When I cut this bottle, let's say from here, and open it, this whole perimeter becomes a side of this rectangle that you see here, and then the height. The height will remain same. I'm just cutting it open, and this side becomes the perimeter. It opens up along the perimeter. That's why this is 2 pi r, and then this is h. So now it's a rectangle for us. So 2 pi r into h, that becomes the area of this one. Okay, of the curved surface. So 2 pi r square plus 2 pi r h. Yeah. Now, this was just the prelude of what we are going to get into. This was just to make sure that we are very clear about how do you find out the volume and surface area of any 3D object, or most commonly used 3D objects. Okay. And again, when it comes to surface area, finding out surface area of different objects, it is going to be more to do with how do you relate, or how do you visualize the object, and then you use your basic understanding of shapes to find out the surface area. So let's look at some real problems rather than relying on what the teacher is doing. Okay? So let's pick up some problems that I have sent for you guys. So before I start, it's only for Emily, and I know Praneet, Tony, Ritika, Jana, everybody might be a little tired of me, including Vishal. This is one concept that we use, that I prescribe, that I have derived for you guys. I call it RAN. Whoever wins the race, see, Praneet is already crying. Who wins the race depends on who ran the best. And what this means is, R stands for read, A stands for analyze or think, and N stands for Nike. Nike, the famous shoe brand, which says just do it. The message here for you all is, if you have any problem to solve, read the problem once, twice, couple of times, or maybe 3-4 times till you are very clear about the question. Then you start thinking about what the question says, how you are going to approach it, what will be your strategy for solving it, and then come to Nike, which says just do it. So you have a problem to solve, read it a couple of times, think about it, make your plan, and then you try solving it. That's the summary. And Emily, welcome to the gang. You will probably end up hearing it a few more times, like what Praneet and other kids have already gone through. Okay? But in a way, it doesn't do any damage to any of you, because it keeps on helping you recollect the fact that any problem that you're trying to solve, don't jump on for solving it. And we'll apply that. Okay? So I have picked up a problem that we are going to talk about real quick. It's a verbose problem. There are a lot of words into it. Big story. And when you hear it a couple of times, then you would know what you have to do. I'm reading the question for you guys. Hear me out carefully. An architect has created a scale drawing for a residential townhouse in the shape of a rectangular prism. An architect has created a scale drawing for a residential townhouse in the shape of a rectangular prism. So you can imagine this is the, I'm just drawing it so that you guys can relate it. Architect was probably better off compared to me when it comes to drawing, but this is how he has drawn it. Okay? An architect has created a scale drawing for a residential townhouse in the shape of a rectangular prism. So what you are seeing here is, at the bottom you have a rectangle, at the top it tapers to become a thin line. Yeah? The internal width of the townhouse is leveled as 11 feet. The internal width, so this width is 18 feet. The internal length is 20 feet. So this is internal length, 20 feet. And the internal height as 30 feet. So height meaning here to here. This height is 30 feet. The local building department tells the architect that if built, the building would be too tall according to local zoning laws. That its height must be reduced by 10%. Okay. So a lot of things. Okay, let me repeat it. An architect has created a scale drawing for a residential townhouse in the shape of a rectangular prism. In the drawing, the internal width of the townhouse is leveled as 18 feet, internal length is 20 feet, and the internal height is 30 feet. The local building department tells the architect that if built, the building would be too tall according to local zoning laws, and that its height must be reduced by 10%. So height, whatever is the height, should be reduced by 10%. 10%. That's the recommendation coming from local building department. If the architect creates a second scale drawing where the townhouse height is reduced by 10%, what will be the new proposed internal volume in cubic feet? Did you guys hear the question?
Can you restate it, please, like the last sentence?
Okay. I'll go from the beginning, okay? An architect has created a scale drawing for a residential townhouse in the shape of a rectangular prism. In the drawing, the internal width of the townhouse is leveled as 18 feet, length is 20 feet, and the internal height is 30 feet. The local building department tells the architect that if built, the building would be too tall according to local zoning laws, and that its height must be reduced by 10%. If the architect creates a second scale drawing where the townhouse's height is reduced by 10%, what will be its new proposed internal volume in cubic feet? Did everybody hear the question? Vishal, Neil, Sarah, Tony, Ritika, Jana, everybody? Yasmita, Vishwa? Okay. So now, Ananya also, yeah, sorry beta. Your name was not appear on the screen, but I knew that you are there. So everybody heard it. Architect created design, these are the dimensions given. The local building department says, no, this is too tall. Reduce the height by 10%. So it says, after we reduce the height by 10%, what will be the new volume of the house in cubic feet? How would you find that out? Saranya, Vishal, are you guys clear about the question? Okay, Ritika clear? Tony clear? Go for it. Yeah, Pradeep.
It would be 3,240 square
3,200?
40.
40?
Yeah.
3,240 what?
Square. Square.
Square foot?
Yes.
Like this?
No, cubed. That'd be the largest one.
Exactly, that's what I was hinting at. I'm not saying that this is the right answer, okay? So Emily, you'll be surprised to know that I'm a very bad teacher and I don't trust anybody. I don't trust anybody when it comes to math. So even if Pradeep is saying this is the answer, I don't trust him. I don't want any of you to trust him. Do your calculation and find it out, okay? Not only for Emily, Ritika, Yasmita, Jana, Viswa, Neil, Sarah, Saranya, everybody, Vishal, okay? Give it a try. Praneeth is a great guy. I don't trust him still. Okay? And you guys have 3 minutes for solving this. While you guys are taking your time, I'll just go and get a chair for myself. Yeah, I made myself comfortable. Yes. Are you guys able to try? Is anybody stuck? Jana, Biswa, Neil, Ritika, anybody stuck or thinking what to do? Tony. Not stuck? Okay. What? 9,720. What we'll do is, we have 2 minutes. So why don't you use notebook and try doing it. I'll tell you this is the reason why I keep describing kids to. You have pen? You can take this. Yeah, it works. No, why I'm saying so is, at least you would know if you are going the right direction or you are missing something. And there are a lot of surprises for Emily, okay? Everybody else knows me. Emily doesn't know me yet. So I always tell everybody that I'm not a very intelligent person, because I want to keep math as simple as possible. And math is actually simple if we make it so. Okay, anybody close to being done? Jasmita, Jana, Viswa, Vishal, Ritika. I'm sorry?
What is it called?
Right, rectangular prism. Emily, what's happening with her? Yes, Jana.
I'm a little confused.
Really confused? Okay, not a problem. Now, let's do voting to see if all the kids want me to do that in the simplest possible way with the little intelligence I have. Yeah? So, Ritika, are you working on it or you would want me to give it a shot? I'm sorry, Beta?
Can you explain?
Okay. So let me solve this like a baby. Let me reduce 45 from my age. So now right now I'm a 5-year-old. Okay? I'm just kidding. So there are dad jokes that you have to deal with. Okay. So what did the question say? I want to make sure that everybody is paying attention to all the blabber that I'm doing right now. Okay? The question said that an architect designed a house like a rectangular pyramid. Yep. Rectangular prism, not rectangular prism. Meaning the base was a rectangle and at the top it was a thin line. It was tapered. Yep. And the dimensions given were 18 feet for the width, 20 feet for the length, and then 30 feet for the height. Okay? When the local building, next part of the question says, the local building department said that it is probably too tall if it is built. So reduce the height by 10%. So earlier height was 30 feet. Reduce by 10%. You are here, but you're not here for next 10 minutes. So not even a single pin has to drop, okay? Alright. Reduce the height by 10%. So, this is too tall, reduce by 10%, means it should be 90% of the current height. So, 90% of 30 feet, or reduce 10%. Rudraj, no sound. Literally no sound. Or reduce by 10%. So, okay, let's do it simple. 10% of 10%. Okay, let me write this like English. 10% of 30. This is what you have to reduce. So 10, it became 3. So by 3 feet we have to reduce. We have to reduce the height by 3 feet. So the height proposed was 30 feet. It has to be reduced by 3 feet. So the new height would be 30 minus 3, which is 27 feet. So the question says, what will be the new volume of this house after the height is reduced? Simple calculation. We have a rectangular prism. We know that volume of a rectangular prism is 1/3 of length times width times height. If it was a perfect cube, meaning it was not tapering, it was like a rectangle, that would have been length times width times height. But when we talk about rectangular prism or when we talk about cone, the volume of those shapes are 1/3 of the volume of its parent. Rectangular prism's parent is a cuboid. Cone's parent is a right cylinder. So 1/3 of this. Now we know my length and width are not changing, so that remains as is. Only my height is changing from 30 to 27. And we have this 18 feet, feet. That is feet times feet times feet. That is feet cubic feet. Now you have 1/3 of 18 into 20 into 27. 27 I can write as 9 into 3, and this 3 and this 3 I can do tic-tac-toe. Then I'm left with 18 into 20 into 9. 18 into 20 is 360 into 9. So 9 times 0 is 0, 9 6 are 54, 5, 9 3 are 27 plus 5, 32. Yeah? 32, 40. So Praneeth and I got the same answer. If I did not do any mistake, then Praneeth also did not do any mistake, and vice versa. Okay? Did everybody get this, the solution part of it? And again, while this question in the beginning was looking, like a little complicated, lot of story into it, but when we read this couple of times, then we realized that okay, somebody has designed the house. Department says no, you cannot have the house this tall. You can keep everything as is, just reduce the height. Reduce the height from 32 by 10%. So this became the house. So what we have been asked is, find out the volume of the new house. Your formula doesn't change, your dimension changed. Length and width remain the same, only your height changed from 30 to 27. Jenna, Ritika, Emily, Vishal, everybody with me? Jasmita, did I explain it okay? So Emily, with the minimum intelligence I have, did I do a decent job? Emily must be thinking that this guy talks a lot unnecessarily. No, but when I'm saying that I have little intelligence, my message to you all is, actually all the problems that we deal with, that just needs a good conceptual understanding and simplest application of it. And the bang for the buck is here. That Praneeth was not really happy about. Because if I just read the question, a big paragraph, and then try solving it, it will be difficult. If I read it a couple of times, the intensity of the program becomes half. A difficulty level comes down. Okay? So, my message to you all is, regardless of how difficult the problem looks, read it 2-3 times, get the problem tired of you, you get tired of the problem. You will see that the problem becomes less difficult compared to what it was looking in the first go. Okay? Let's look at one more problem. We have just 5 more minutes for today, but tomorrow we will actually do more practice. Today we kind of ran through the concept one more time to make sure that we get the concepts right. And tomorrow when we do practice, we'll do a little more practice, and I will let you guys break your head a little bit more. And breaking the head essentially means that if we pick up problems after problems after problems, right, that discomfort, it's like seeing a ghost. Till you have not seen the ghost, you are afraid of it. When you start seeing the ghost very often, the fear of ghost is gone. Right? Then you're okay, ghost is normal, it's okay. So they are the ghosts we are talking about. Let me read one more question for you guys. and we'll just focus on the concept or the approach part of it. Water is poured into a rectangular container 10 centimeters long. Water is poured into a rectangular container. So, this is a rectangle. Water is poured into a rectangular container. So, actually it has some height also. That's why it's a container, right? I cannot pour water into a rectangle. Right? So, essentially it's talking about a cuboid. Okay? Which is 10 centimeters long. This is 10 centimeters long. 12 centimeters wide. 12 centimeters wide. And 9 centimeter height. This is 9 centimeters. Water is poured into a rectangular container 10 centimeters long, 12 centimeter wide and 9 centimeter high. Until it is 1/20th full. So this container has some dimensions. It says water is poured into it till it is 1/20th full. All this water is then poured into a empty cylindrical container. Okay? Empty cylindrical container. With a base radius of 3 centimeter. 3 centimeter. Height of the water in the cylindrical container is y. So when you see, this was a container where you had filled water till 1/20th of the whole volume, and then you pour that water into the cylinder. It says water is filled till y over pi height centimeters, where y is a constant. What is the value of y? So we are talking about a volume in this rectangular container or cuboid till 1/20th of the volume, and then you pour that into this cylinder with a radius of 3 centimeters, and it is filled till this height, y over pi. We have been asked to find out what is the value of y. So here, if you look at it from approach point of view, what it says, what is the volume of this guy? Length times width times height. What is length times width times height? 10 into 12 into 9. This is the total volume. It says it is filled 1/20th of the full volume. So this much is the volume of the water. Now this is the volume, and if you are filling that in the cylinder, how much is the volume of the cylinder? Let's say water is filled till y over h. So pi r square h. R is 3 square into h. H is your y over pi. So this volume is equal to this. Find out the value of y. That's it. So I know I rushed through this problem, but again the same thing. Whatever information we have, read it a couple of times, then visualize you doing it, and then you can try relating it with the formulas, the concepts that we know. It'll be fairly straightforward. So we'll muddle the water a little bit more. We just tried pouring water from here to here, but that is not enough. We'll muddle the water more in the class tomorrow, and that will get rid of some of the ghosts that we are afraid of right now. Alright? Okay. So with that being said, I will let you guys go. Enjoy the rest of your evening. Any doubt, any questions, don't hesitate to reach out to me. Okay? We'll talk again.